This is the B level, finding surface area of composite and hollow solids. Basically here, we just need to be careful breaking down these shapes. Take this first one. We have basically what is a cylinder and a cone, but we don't have all of the parts of the cylinder and all of the parts of the cone because they're pushed together. So we think of surface area as paintable area. So there are three general shapes that I see here. The first of which is the lateral surface of the cone. So we know that as kind of the Pac-Man shape. The formula for that, pi r slant height. We then have the lateral surface of the cylinder, and that is of course a rectangle with a 2 pi r as our circumference there, and the height is 5. And then finally we have a circle, and the circle has a radius of 2, and of course we'll just use the formula pi r squared for that. So there's no one way to do it. You just have to break them into the shapes and add them together. So the three things that we need to add together here: pi times the radius times the slant height plus pi times the radius for the circle at the bottom, which is also 2 squared, plus this rectangle, which is going to be 2 times pi times 2, all times 5. And we're just going to add all of those things together. When you enter all of those onto your calculator, we end up with 119.38. We're going to round that to 0.4 cubic square inches. All right, I'm going to set up this next one with you, but I'll let you calculate them. We have 4 triangles on the outside. So I'll put a triangle and it's times 4. The slant height of that is 10, and the base is going to be 8. And then we have a square, and actually we have the same square that the outside is, the lateral surface, is as the bottom. They're all 8 by 8. So we got an 8 by 8, and there are 5 of those. So find the area of those things, multiply by the respective multiples, and add them together. Well, let's focus on number 3. This one is the real tricky problem because what we're imagining here is that this is a kind of a hollowed out piece of the prism. So we've got this chunk taken out. Now, if this was just volume, we would be able to take the outer volume, subtract the inner, kind of like we did with area. But taking out chunks actually creates more surface area. So we're going to have to draw a bunch of different shapes here to represent what's going on. First, the top and the bottom are going to be the same. So I'll draw that shape. This is a 10 by 7. And the inner portion is a 4 by 3. And we're going to have 2 of those once we find the area of that. Then I'm going to work my way around the shape. So we've got a front shape that has a 10 by 5. And since we have 2 of these, front and back, we'll go times 2 on that one. So that takes care of kind of this side. Let's go to the right. This dimension is a 7 by 5. 7 by 5. We've got 2 of those, right and left. Now let's get to the inside shapes. The inside, we've got a length of 3 and a height of 5. We've got 2 of those. And then the back and front of the inside is a length of 4 by 5. And we've got 2 of those. So we've got kind of pairs of everything. So we're just going to go through and find the area of all of these things. And then we'll have to double them once we get, once we find all the lengths of these things. So we got 35, here's 15, here's 20. This one is going to be 70 minus 12. So 10 times 7 minus 4 times 3. That's 58. right there. Oops. And now we'll just start doubling everything. 58 times 2 is 116. 50 times 2 is 100. 35 times 2 is 70. 15 times 2 is 30. 20 times 2 is 40. So we're just adding all of this up. 116. And we end up with 356 square units.